All right, so let's now take a look at the test I just gave back to you, and let's go through it. If you got a problem, if you got it wrong the second time, and you don't know what you did, you definitely should be asking about that problem. Okay. If you know what you did wrong, you're like, oh, okay, I just missed a negative, right? Whatever. Okay. You may not have to ask about it, but this whole class period is just dedicated to go over this test. All right. So let's take advantage of it if you need it. All right. What about right here? 1 and 2. Right? You plug in 3 for x and 1 for y, and you see if it works. And if they both work, then is it a solution? Yes, it is. Okay. If it doesn't work, then it's not. Even if only one of them works and one of them doesn't work, it's still not a solution to both of those. Okay? Any questions on 1 and 2? Now's the time to ask. Don't be shy. All right. Solve graphically. Okay, you had to graph both of those, right? Then you had to find out where they did what? Where they intersected. Okay, you had to find out where they intersected. All right, and so this one intersected at 1, -3, and this one intersected at -2, 2. This is where, remember how I always talk about it's important to be accurate, especially when I did the slopes. Remember if the slopes are real close to each other, like 1/2, I went 1/2, 1/2, 1/2 several times, right, to make sure it was accurate. This is a situation where it's very, very helpful to be very accurate with your graphs so you know exactly where they intersect each other. All right, so make sure that you're accurate. Ask a question about this if you have one. Now's the time. Nobody?
Can you not give us a question on the future test that clears that it goes off the graph?
That was one problem. Believe me, when I was looking at the homeworks, I put several on there, and then when I went to actually do the answer key thing, there were several that were way off the graph, and I had to go back and change it so that it would stay on the graph. So I did make an effort to try to keep it on the graph. That one kind of slipped through the cracks on me. Which one was it? This one? Was it?
It was 18.
18? Okay. But you could have figured that out. It was only one off, right? You could have just gone one up. I know. But I did, just so you know, I really did go through them all and tried to make sure that everything did lie on the graph. That one I just missed. So sorry about that. All right, what about these right here? I gave you a bunch of these to do. Now, obviously, on the midterm, I'm not going to give you as many of these because I'm only giving you 40, and I got 60 problems to choose from. All right, so anyway, I'm not going to give you all 6 of these, but I'll give you 2 or 3. It's all from the test. Yeah, just know the test. What's that?
40, my two.
Didn't I just say it? I thought I just said it. Okay. So, come on, we're not doing much today. Which one do you want to do? Let's just say that. Which one do you want to do? 9?
Can we do 18? No, can we do 18 first?
18? That's the one that went off the graph? Right.
Then it wasn't easy then.
Had to be fairly easy. I probably got more 100s. Let me do this. Yeah, let me scooch that in a little bit just so I can fit my graph. All right, there we go. I gotta move this white over because it's a white graph. You're not going to be able to see it. Now it's too big. What in the world am I doing? Let's try this again. Can I make this? Can I just make this black? Maybe? Oops. Oh, this is not going as planned. Okay, let's click off of it. Oh, no wonder it's white. That's why.
I think wait, no,
There we
go to
go.
the top left.
Let me do it. Oh, what did I just do? All right. I thought I just clicked on. Oh, this is driving me nuts. This is not working out like I wanted it to.
Well, you see the box with the
Ah,
square at the side
I
of it?
know. No. It seems like I did connect it to the paper.
Wait, I have a question.
What?
You see
Why
the box
is it?
with the color inside of it? You see that like white box at the very top of your screen?
Yes. I know how to do it. I'm just not doing it. I don't know why.
I think you should do it from there.
Here, I'm gonna do it. I'm gonna do it over here. Then I'm gonna try to make it black. Yeah. Let's instead of that, let's make it that. There we go. Come on. Yeah, now it's way too big, so I'll just try to get it to fit in. There we go. I did it. Took me forever, but you get the idea. All right, so what are we doing? 18? Oh, I should slide it down. Oh. What's going on? This is not my day. All right. Can we see it there? Yeah. We don't care about that quadrant anyway, do we? So it doesn't really make any difference. Keep clicking on that. There we go. All right. I think we're finally ready to do this. All right, so what does this mean? X is greater than or equal to 0. So it means it's the y-axis, isn't it? All right, and it's greater than 0, so it's everything what? To the right of the y-axis. This is y is greater than or equal to 0, which means it's everything above the x-axis. So basically, this thing right here just tells me what? That I'm in the first quadrant, exactly right. So that's what that's telling me. Okay, I'm not even going to graph that. I'm just going to recognize that that's what that does. So what do I need to graph these two. So I can graph this pretty easy. So this is going to be, let's make this a little thinner. Okay, so let's graph this one right here, but I'm going to put it into slope-intercept form. I don't think that was the issue on this problem. I'm just going to put a equals. And then it's going to be negative x plus 15 divided by 3. So it's y equals negative 1/3 x plus 5. So let's graph that. Can you remember that? Can you? Because I got to scooch it up a little bit. Negative 1/3 x plus 5. So plus 5. So I'm going to go 1, 2, 3, 4, 5. Negative 1/3. So go down 1, 1, 2, 3. I'm going to do it a few times again, like I talked about earlier, just to be precise. Down 1, 1, 2, 3. Down 1. I don't even have to do it anymore. It's good like that. All right, so that goes like this. And again, on these, it's pretty helpful. I don't even care how far I go off to the left because I'm only going to deal with the first quadrant anyway, correct? All right, so I got that one. The next one's a little easier. Just subtract a y from both sides. So y equals what? Negative x plus 7. There's your 7. That's the one on the graph that went off because they only had 6 blocks on the graph on the test. What was the slope? Negative 1. All right, we'll just keep everything. We'll keep everything red, I guess. So 7. 1, 2, 3, 4, 5, 6, 7. Well, this one's got 7 on it, doesn't it? Oops. There we go. And negative 1. Or I could do what? Negative 7 over what? Positive 7, right? Now, on yours, right, you only went 6 on the graph. So you would have just had to, like, let's pretend this was the 6, okay? Just go up 1 over 1 like this. And this would have just been like over 1 down 1. That was the only thing different, okay? So I don't think it was out of, I don't know, what's the word I want to use? I don't know. I think you should have still been able to do it. Put it that way. All right, so let's connect those like this. All right, and that's everything. Now let's do the inequality though. So I know I'm in the first quadrant, and what's this one? This one is less than or equal, so that's this first one. Probably should have color-coded them, but that's all right. This was which one was my first one? This one right here, right? That was my first one. So it's everything below this, and it's everything below the other one as well. Yep, because they're both less than. So where's the shaded region? It's just all this stuff. And it stops at the axes, the x and y axis. So it's all this stuff. Okay, why do we care about the shading? Because I want to find the vertices. Was it somebody in this class asked what a vertex was? Yeah. What are the vertices? Look, it's this. It's where they come together, okay? It's where they come together. So that, and also that right there. So those are my 4 vertices. Vertices is just plural for what? Vertex. All right, so now I just got to figure out what they are. So let's just drop this a little bit. Get rid of some of this writing. Oops, don't want to do that. There we go. Get rid of some of this. Okay. And let's see if I can scooch it. There we go. All right, so what are my points now? Let's go back to red. So what's this point right here? 0, 0. And this is the key to this problem. Really, the key to the problem is finding the 4 vertices. I got 0, 0. What's this one? 0. How far did I go up? 5? 1, 2, 3, 4, 5. So 0, 5. And then this one. Now, this is the hardest one because you already knew you had these axes right there. All right, but this was the one where it wasn't actually on an axis. And this is why it's important to be able to graph these accurately. So what's that point? 1, 2, 3, 1, 2, 3, 4. So that's 3, 4. And then our last point is what? 5, 0? Okay. Now we don't need our graph anymore. Okay, so we're done with the graph. What are we going to do with those points? We're putting them into this function right here. All right, and then we're going to look at what they come out to be, and we're going to look for the maximum, for the biggest number. All right, so let's put them in. That's just going to be 0, right? 2 times 0 is 0, plus 5 times 0 is 0, 0 plus 0 is 0. All right, 0, 5. So that means x is 0, plus 5 times 5 is 25. Let's go 3 and 4. So 2 times 3 is what? 6, plus 5 times 4 is 20, and that is 26. Let's do the 5, 0. So 2 times 5 is 10, plus 5 times 0 is 0. That's just 10. Which one's the biggest number? 26. So this is how you write your answer. You're going to write f of what? 3, 4 equals 26. And that's how you write that answer. Some people just put 26 and circled it, and I gave it to you. But technically, you should write it like this. We good? What else? What about these shading things? Now's the time to ask. I'm not going to bring you up here, make you do it, or anything like that. Just tell me, and I'll just go through it and show you how to do it.
For the functions which comes off as Kenny Harris, Savon Brown, Sayer Robinson. Thank you.
So many announcements, my word. What's that? 14? This one right here? Okay, doke. It says solve graphically. So we got a graph right there. I'll just use that one. Let's hopefully see if I can get rid of all that mess. All right, so I got to click off of that one, click off of the graph, and click off the white. There we go. That was nice. So 14 is the question. Here we go. It's an absolute value. What's an absolute value look like? A V, right? And then where does the V start? You can look at it. Right, this means it goes to the what? To the left. Even though it's a plus, it means it goes to the left 3 places. 1, 2, 3. What does that minus 2 mean? It means it does. It goes down 2 right there. So that's our starting point, our vertex. Okay? It's absolute value, and it's less than or what? Equal to, so it is going to be a solid line. But where's the V? How do I know how far to stretch the V out? Well, it's just up 1 over 1. It's kind of like it kind of like has a slope of positive 1 and negative 1. All right? So there's one, there's another one. Now watch, I could keep putting them on there, right, just to make sure that I'm accurate. See that? Right? Up 1 over 1 for all of those. It's not hard, is it? Everybody should be able to figure that out at this point. And where's my line thingy? There it is. And then, so it looks like that. We'll do the shading in a second. All right, let's graph the other one, though. What does this one mean? This one means it goes to the right one place. All right, so it goes right here. That's the starting point right there. It doesn't go up or down because there's no plus or minus on the end of it. And again, so what do? Up 1 over 1, up 1 over 1. And then you could keep putting the points on here, again, just to make sure you're accurate. Right here. Okay, and it says or equal as well. So what kind of line is it, Matu? That's a dotted line. It doesn't say or equal to. What does it say, Matu? It just says greater than, so it's not or equal, so we just put dotted. I'll just hand dot them. One day I'm going to figure out how to do a dotted line on here, and I know if I could just, I never think about it until I'm actually doing it here. All right, let's do the whatchamacallits, the shading.
What's the software called?
This is called Adobe Illustrator. So what's it say? It says less than, which one? We're doing this one. This says greater than. The first one says greater than the solid one. Okay, so what does that mean? It means it's everything where? Above. Okay. What number is this? 14. Just looking at mine just to make sure. Okay, so it's everything above. So basically, if all I did was just graph that and nothing else, all of this inside that V would be shaded, correct? But it says it also has to have this. So we're finding where they come together, where it works for both of them. So it's got to be everything inside of here, but this one says it's got to be everything where? Inside of the dotted one. So am I going to put anything in this area right here? No, because it's not above the first one. Okay? Am I going to put anything here? No, because it's not above the dotted one. So where am I going to put my shading? Just the stuff from here to here. Okay? And that's my shading right there. Make sense? All right, because it's got to satisfy both of those. So it has to be true for both of them. So this stuff in here would be true for the first one, but not the second one. This stuff right here would be shaded if it was true for the second one, but that's not true for the first one. So only what's true for what satisfies both of those. We good? Okay, what else? We got time. 19? All right, yeah, let's do one of these. All right, I got room down here to do all this. All right, so let's do 19. I set this up. Well, I just grabbed the problem from homework. Yeah, I didn't set it up. But I picked it, though. I hand-picked it because of certain things. What can you do? Let's see. Elimination, I think, is what we want to do here. What's the easiest thing to eliminate? The first and the second one, right? And eliminate the z's. So that's what I would do. So let's write it down. X plus 3y plus z equals negative 8. And then 4x minus 2y minus z equals negative 9. You might have been able to just do this part in your head, but I'm going to write everything down. All right, so I took the first two, and look what happens. When I add up all three of these columns, the z's cancel out. But I got to add up the other columns as well. So 1x plus 4x, 5x. 3y minus 2y is y, positive y, so it's a plus y. That canceled, and that equals, add up those, what? Negative 17. With me so far? All right, I'm going to hang on to that. You don't have to put it in a box. I like to, because you're going to have so much stuff all over the place. right? It's hard to keep track of everything. So I like to put that in a box. Now what you could do is you could use the first one and the third one, eliminate the z's, or the second one and the third one. I would do the second one and the third one. Why would I do that? Because one's already negative, one's positive. But what am I going to have to do to that second one, though? I'm going to have to multiply it by a 2. Not ma 2, but a 2. All right? Sorry. It was just hanging there. I had to go for it. All right. So watch. Let's do it. Multiply this side by 2. So I've got 8x minus 4y minus 2z equals negative 18. And why did I multiply it by 2? Because I want this to be a negative 2z, because this is a plus 2z, and I want them to cancel out. Okay? The bottom one, I didn't have to do anything to that, so I'm just going to keep that the same. Plus 2z equals negative 19. All right. Everybody with me? So now what happens? Those cancel out. Add up all the other columns. 13x. What's that? Minus y. That canceled. And this is negative, what's that? 37. Is that right? Do the math right? Yep. All right, so that's my other one. Now, if I got two equations with the same two unknowns, I should be able to do another substitution and solve for it. Man, this thing works out nice and easy because look, I got a plus y and a minus y. What did I say? Yes, I meant elimination. Thank you. I guess you could do substitution, but I wouldn't. I would do elimination. So let's do it. 5x plus y equals negative 17. And then 13x minus y equals negative 37. So look, the y's eliminate right away. All right, then add up all the columns. I got 18x equals negative, what's that, 54. Divide both sides by 18. Is that 3? Negative 3? Yep. All right, so there's my first one, okay? Once I get one, the rest of them should just fall into place pretty easy. I could use any of these equations up here. I'd probably use this one right here, wouldn't you? Yeah, let's use that one. So what do I get? 5x, or 5 times negative 3, plus y equals negative 17. This is negative 15. Let's do this in one step, okay? How do I get rid of a negative 15? I add a 15, so y is negative 2. So there's my x, there's my y. Now I got to find a z. Which one do you think the easiest place to put the... Yeah, I would go the first one, okay, because z is already by itself. It's already positive. So let's do it. So I'm going to rewrite the first equation. So x, which is negative 3, plus 3y, which is 3 times negative 2, plus z, and that equals negative 8. Just do the math. This is negative 6 minus 3 is negative 9. Add a 9 to both sides. Negative 8 plus 9 is 1. There you go. But you put them all together. How do you write it? Negative 3, negative 2, positive 1. And there you go.
I go to the bathroom.
There you go. All right. What else? Anything else? Half of you don't have to take it, so you're not asking me any questions. And half of you, well, not quite half, but a bunch of you got 100% on it, so you probably don't have any questions because of that. Anybody else? Let's take a look at them again. Have we done one from each? We didn't do that. But you know how to do that, right? 15? Okay. All right, let's get rid of this graph stuff before we'll use the same graph. Oops. All right, how am I? Did I get rid of that? Don't want that. Let's see. There we go. All right, that's what I wanted. All right, which one doing? 15? Okay. Negative x plus 1. So this one's not a absolute value, right? The first one. It's just negative x plus 1. So the y-intercept is 1. Whoops. I'm not going to be able to. Using white, it's not going to. Yeah, let's go green. Haven't used green. We'll go Christmas. Red and green.
Oh, I like that.
All right, and now what was the slope? Negative 1? All right, so I go down 1 to the right 1, and I could just keep going this way a few, go up this way. All right, and then was it dotted or solid? Dotted. Both of these are dotted. Ugh. What's that?
What did you put on your Christmas list?
Christmas list? Do I have a Christmas list?
You still get your kids presents? Because they're like grown? Well, they get some like belts.
I'm almost 60 years old, and my mom and dad still give me presents. So
Yeah, so what did you put on your Christmas list?
I am getting what do you call it? No, it's like a drill, but it's it kind of no. It's an impact drill. It's an impact. You ever hear those? They're like it's a battery powered wireless drill, but it goes boom 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 like this. So it really goes through the wood a lot easier than just a regular drill that spins. So my fence fell down the other day, and my friend Alex used to sit right there where Hunter's sitting in this class. I called him up. He's a friend of mine now, and he's got a truck, and we went and got it's just the panel fell down, and it was so old. I put it up long time ago. So anyway, he had an impact drill, and it just worked so nice. And I thought, ooh, I need one of those. And so I asked my dad for that. I like all candy. Candy's my favorite.
I'm going to bring you in on my special cookie.
In fact, they were selling candy out front, right? They had hot chocolate and stuff.
Oh, I saw you getting that.
And so I go up, and they said, oh, do you want coffee or hot chocolate? And I was looking around, and like, I know you don't want candy. I'm like, well, you don't know me very well, because I love candy. So I got some candy. A cookie? Yeah, I like cookies. All right, here we go. Are we finished this yet? So here's that one. And this is x plus 2. It's absolute value, x plus 2. What is that plus 2? It goes to the left. And this goes up 1 like this. And this goes up 1 to the left 1. Right, we've done those already, so you get the idea. So that goes like that. And this, I can't write from right to left. I got to write this way. All right. So it looks like that. So what's our shading, though? Are both of these, let's see, they're both less than, correct? So everybody look. So everything is less than this diagonal line, and it's less than this this v, this absolute value. So less means everything below it, or in this case, to the left. But am I going to put stuff in here? No, because I got to go below the v. If I go below the v, it's all this stuff. But I'm not going to do here. This would be below the v, but it's not below this diagonal line. So this is my stuff that's shaded. What do you mean, how did that work? I just did it. That means, look, if I pick any point inside of here, any point, okay? Right here? Because it's absolute value. And that's what an absolute value looks like. We went through why it worked, right? If you do this, if you go x, y, what was it? Y equals what? Absolute value of x plus 2. Like that. Anyway, that's a plus 2. I made that terrible. All right, but get the idea. Watch. If I let's put a few negatives in there, like -3, -2, -1, 0, 1, 2, 3. Okay? This is why it works, but you don't have to go through this all the time. It's like reinventing the wheel every single time you graph. All right, so watch, -3. What's -3 plus 2? -1. What's the absolute value? No, -3 plus 2 is -1. Absolute value is 1, so that's a 1. So -3, 1. 1, 2, 3, 1. Boom, right there, right where we said it was going to be. See that? -2. What's -2 plus 2? 0. Absolute value. Why do you keep saying wrong answers? -2 plus 2 is 0. Absolute value is 0. Put in -1. -1 plus 2 is 1. Absolute value is 1. Put a 0 in there. 0 plus 2 is 2. Absolute value is 2. You get the idea, right? Put a 1 in there. 1 plus 2 is 3, and so on. It just gets bigger and bigger. I could put more negatives in there if I wanted to. But look what happens. -2, 0. Boom, right there. That's why we moved it to the left 0, because it's -2, 0. Or we moved it to the left -2 because it's -2, 0. -1, 1. Look, it lies right here. 0, 2. It lies right here. See it? All right, that's why. And I could put more negatives in there and you would see that they would lie right on that line. So that's why it works. But once you understand how an absolute value works, then you could just look at it and say, oh, that plus 2 moved it where? To the left 2 places. And what's my slope, if you want to call it that? I don't think I've ever heard anybody call it the slope of this. Maybe they do. I just never seen it. But look, 1 over 1. You see that? 1 over -1. All right? And then you just keep going that way, keep going that way. So that's why it looks like a V. But we don't have to do this every time. That would be a pain, wouldn't it? It was so much easier just looking at it and saying, oh, I've seen this before. That plus 2 means it goes to the left, and I go up 1 over 1. And then just draw the line from there. Make sense? Okay. Is that it? Anything else on here? Now it's time. We didn't do any of these. Well, we kind of did one, right? When we did that last one, we kind of did 2 of them. All right. That's all I got then. Now, tomorrow we're going to go back to chapter 1. All right. You may not remember a lot of that stuff from chapter 1. So be ready. No, we're going to do 2 as well. But tomorrow is Wednesday. We'll do chapter 1. Thursday, chapter 2. And then we'll have it all ready to go. All right. Enough of that.